All right, guys, we are going to add to our notebooks. And if you're keeping up with the table of contents, it might feel like we're done. We're actually kind of not. But we're going to add 63 and 64 today. And we're going to talk about graphing inequalities in two variables. We also actually have two more little mini sections to do after that. So we're going to be adding a little bit more to this. That's my bad. I added some stuff at the end that I think will be good and prepare us for the next chapter. So if you guys remember, inequalities are like greater than and less than symbols. And we did graph those before, but we graphed them in one variable because we just did it on a number line. And we talked about an open or closed circle and then pointing to the left, pointing to the right. Those things are still going to be important here when we think about graphing in two variables. So that just means on the x and the y-axis, what does that look like? Okay, so if we turn to page 63 and 64, I'm going to start on 64, and these are going to be our steps for success in graphing a linear inequality in two variables. The first thing that you're always going to want to do is put it into y equals mx plus b. Now your equal sign won't really be equals. It's going to be something like greater or less or greater than or equal to or less than or equal to. Okay. But you do want to get y by itself. Second thing you'll do is you'll plot your y-intercept, which is b. Then you will do slope as like rise over run, which is m. But then you have to do more. So you have to be really careful. It's really exciting to like graph your dot and do your slope and then draw your line. You have to be so careful here. When you draw your line, it might be a dashed line or it might be a solid line. So it will be a dashed line if it's not equal to, and it will be a solid line if it's equal to. And I can kind of tell because like this already has a solid line in it. So that's going to tell me that it's a solid line. If it doesn't already have the line underneath it, then it's just going to be a doot, like a dotty line. Okay. And then this is super fun because you get to color. So then you should ask yourself after that, do I shade above or do I shade below? So you'll shade above if it's greater or greater than or equal to. And you'll shade below the line if it's less than or less than or equal to. Okay. So again, just as a little reminder over here, a solid line will be because we are greater than or equal to or less than or equal to. It has to do with the equal to. It will be a dashed line if it's just greater or less. Now, when I say shade above, this can look like a couple of different things depending on what sort of line you have. Like if I have a positive line and I shade above, that's up here. But if I have a negative line, it looks a little different. But you're going to do that if it's greater or greater than or equal to. And you'll shade below. So let's say I do have a negative sloping line. Below the line is like down here. You shade below if you are less or less than or equal to. Okay, so a real quick example. This is not in y equals mx plus b. So I'd have to get y alone by subtracting 2x on both sides. So we'd have negative 3y equals, oop, no, it's not. It's less than, whoops, negative 2x plus 12. Then I got to divide everything by negative 3. And so, Big reminder. If you multiply or divide by a negative, switch the inequality. So right here, because I'm dividing by a negative, that was kind of like our golden rule. If you divide by a negative or multiply by one, this inequality needs to switch. So now it's going to be greater. Now negative divided by a negative is a positive, so 2/3 x is my slope. And then 12 divided by negative 3 is a negative 4. Okay, so I go and I plot my y-intercept, which is at negative 4. 1, 2, 3, 4. Then I do my slope, which is up 2 over 3. So up 1, 2 over 1, 2, 3, forward. Up 2, forward 3. Up 2, forward 3. And then I need to pause and think, should this be a dashed line or should it be a solid one? And so because there's not a line underneath, it's going to be dashed. So I make this sort of like a dashed line or a dotted line. And then I need to think about shading. Will I shade above or will I shade below? And so since this is greater than, I shade above. So that's all this stuff up here. Now guys, I think it's easy enough to just think about above the line and below the line, but we can also use test points to help us know for sure. Okay, so we're going to do a whole bunch of practice problems on the next page here where we kind of use some test points to see if we've shaded in the right spots or not. Okay, so if we jump over to page 63, oh my gosh, I should have told you too, in the packet, I want to say that this is the 16th page, but there are 2 of them. You only need to do 1. And then this should be the 17th page. I might have those backwards though. I should have said that. I'm so sorry. I'll put it in the notes for this video. Okay. Now, if I look at the front here, all of these already have y all by themselves, so we don't need to worry about that first step. What I should be thinking about is what is my y-intercept and what is my slope. So there is no number being added or subtracted, so my y-intercept is 0, and this has a slope of 1, so up 1 over 1, up 1 over 1. So we get this line here. Now this symbol is less than, and there's no line underneath, so that's going to be dashed. And because we are less is below, and so that would be down here. But to feel really good about that, another thing that we can do is see if the points are part of the solution or not. So if I plot the point negative 3, comma 2, negative 3, comma 2, that is not part of the solution. And I can also tell from the equation, like if I plug in x for x and y for y, 2 is not less than negative 3. And it should not be in the shaded region either. So it is not a solution. 0, 0, if I think about plugging it in, 0 is not less than 0. So it should not be a solution. And it's not, even though it's on the line, it's on a dashed line, and dash doesn't mean equal. Now 2, comma 1, so 2, comma 1 is in the shaded region. Also, if I plug in x and y, I have that 1 is less than 2, and it is. So that is a solution. And we can kind of tell because we can plot it, and it's in the shaded region, or I can plug it in, either way. Okay? So another one here. This line is the same line, and it's still dashed because it's not equal to. But now it's greater than, and greater than is above. So that's all this stuff. That's not a very good dashed line. I swear it's dashed. There we go. So negative 3 comma 2, we can think about this a couple of ways. If I go to negative 3 comma 2, that does fall within the shaded region. Also, if I think about plugging it in, 2 is greater than negative 3. So it should be shaded. Now 0, 0 is on the line, and the line is dashed, so not equal to. And then 2 comma 1 is right here in that non-shaded region, so it's not a solution. Also, if I plug it in, 1 is not greater than 2. Okay, so there's kind of two ways we can know. These two are also the same line, so we'll get that same line going. However, it is now a solid line because we have the line underneath. So solid. And it's still less, like the one above it, so we'll shade below. And if we go with just like graphing the points, if I go to negative 3 comma 2, it's not in the shaded region, so it's not a solution. 0, 0, even though I did a bad job graphing, that is part of the solution now because the line is solid and I am equal to. 0 is less than or equal to 0. So it is a solution. And then so is 2 comma 1 because that's part of the shaded region. So they are both solutions. And then last but not least here, this one here would also be a solid line because it's equal to, we got this line here. Let's do a better job. I should have grabbed a straight edge. But in this case, it's greater, so I shade above. And then if we think about these ordered pairs here at negative 3 comma 2, that's within the shaded region, so it's a solution. 0, 0 is on a solid filled in line, so it is a solution. But 2 comma 1 is outside the shaded region, so it's not. Oh my goodness, there's so many more to do on the inside here. So what you guys could do is you could pause and try some of them and come back and see how you do because I'm going to do these fast, okay? So these ones are all super nice. They're already in y equals mx plus b. I'm just going to plot my y-intercept at negative 2 and then do my slope of up 3 over 1, up 3 over 1. This will be a dashed line because it's not equal to. And it's less, so I'll shade below, which is all this stuff over here. Then when I think about the points that are solutions, negative 3 comma 2 isn't, 0, 0 isn't, 1 comma 4 is not, 2 comma negative 5, hey, that one fits in right down there, so that one is. 0 comma negative 2 is not because it's on the dashed portion. Negative 4, 2, 3, comma negative 2 is not. 2 comma 2 is, because that's within the shaded region. Negative 2 comma 3 is not. And then 3 comma 0 is. Okay. On this next one, my y-intercept is at 4. My slope is down 2, forward 3. So down 2, forward 3. Or I could have gone up 2, backward 3, but it kind of doesn't fit. Now, this line will be dashed because it's not equal to. And it's less. So sometimes what I'll do, guys, like I'll put my pencil and like to be less, I have to be below. So I have to move my pen down. So that's all this stuff that's less. Okay, so negative 3 comma 2 is in there. 0, 0 is in there. 1 comma 4, 1, 2, 3, 4 is not in there. 2 comma negative 5 is in there. 0 comma negative 2 is in there. Negative 4 comma negative 2 is in there. This is a big old shaded region. It's got a lot of solutions in there. 2, 2 is in there. -2, 3 is in there. And 3, 0 is in there. Dang, lots of them are in there. All right. On to the next. This line has a y-intercept of -4, but has a slope of 0 because there is no x. And a 0 slope is just a horizontal line. It will be dashed because it's not equal to. Then to go below that, I mean, here it is. Below is just down. Hopefully that kind of makes sense. So like it doesn't look like a lot, but there's a lot that is below -4 that I'm just not seeing in this picture here. Oh my God, it's greater. Oh, dang it. Wah, wah. Oh my God, that's a greater than. I'm not redoing it. It's greater. Oh my gosh, guys, I'm so sorry. I promise I won't mess up in class when we actually do these notes together if you're watching these on your own. Sorry. Okay, it's greater. So above. I just read the sign wrong. I was getting too excited about all my less thans. So, okay, -3, 2, that's in. 0, 0, that's in. 1, 4, that's in. 2, -5. Ooh, that's not in. Not in. 0, -2, that's in. -4, 1, 2, 3, 4, -2, that's in. 2, 2, that's in. -2, 3, that's in. And then 3, 0, that's in. I'm so sorry, I kicked that one up. Okay, last one across the top. We got a y-intercept of -2. I was just so excited to talk about a horizontal line with you that I forgot to read my symbol correctly. Then I would go and do my slope, which is -1. So down 1, forward 1. Or up 1, back 1. It will be a dashed line because it's not equal to. And this one is greater, like the last. So again, sometimes it helps to put your pen and like I want to push the pen up because it's greater. So that's all this stuff up here. But not the line, which is something to keep in mind when we're checking these points. So if we go to -3, 2, that's in. 0, 0, that's in. 1, 4, that's super in. 2, -5, ooh, just out. It's not out. 0, -2, that is not in because it's on a dashed line, so not equal to. -4, -2, not in. 2, 2, that's in. -2, 3, that's in. And then 3, 0, that's in. Yay. Okay, we got 4 more to try. This is going to be a long video. I'm so sorry. Okay. Right here, we got a y-intercept of -4. 1, 2, 3, 4. A slope of -2. So I would go down 2, forward 1, but I kind of can't. So instead, I'll go up 2, back 1. Now this line is going to be solid because it's equal to. And then that's a less than symbol. So that's going to go this way. I need to move my pen down. So less is over here. And guys, again, if you're ever not sure which way you should shade, just pick a point. Like 0, 0 is always a good one. If I go with 0, 0 and I plug that in, I'd have 0 is less than or equal. Now 0 times -2 will just go away. Is 0 less than or equal to -4? It's not. So that should not be shaded. Also, that tells me that that's not part of the solution. Okay. Now that I feel good about where we've shaded, I can check the rest of these. So -3, 2, that's in. That's on the line. Oh my God, and it's a solid filled in line now. 0, 0 wasn't. 1, 4 is super not. 2, -5 is not. 0, -2 is not. I almost said that was. It's not. -4, 1, 2, 3, 4, comma, -2. That one is. 2, 2 is not. -2, comma, 3 is not. And then 3, comma, 0 is not. Oh my gosh, sorry about the bell. This one, ooh. I probably should put it in y equals mx plus b, but we can do it quick. So if I block that out, x is 3. If I block that out, y is 2. And there are no negatives. That's why you can kind of do it this way. If there are negatives, then your sign might get switched. So that's why you want to be careful. Now it's equal to, so it's going to be a solid filled in line. And it's less, so less is below. And all your solutions are -3, 2, 0, 0, 2, -5, 0, -2, -4, -2, 2, 2 is not, -2, 3 is, and 3, comma 0 is. That was fast. Okay, here we go. Last two. I plot -1. We go up 1, 2, 3 over 2. We get a solid line that is shaded, that's greater, so above. -3, comma 2 is a solution, 0, 0 is, 1, comma 4 is, 2, -5 is not, 0, comma -2 is not, -4, comma -2 is, 2, 2 is, -2, comma 3 is, 3, comma 0 is not. Now this last line, it's exciting. It's an x equal line. That is vertical at -2, and it is solid because it's equal to. And then x is greater. So I have to think about which way do I need to go to be greater? And that would be over here. And so -3, comma 2 is not, 0, 0 is, 1, 4 is, 2, comma -5 is, 0, -2 is, -4, -2 is not, 2, 2 is, -2, comma 3 is because it's on the line, 3, comma 0 is. Oh my gosh, I'm sorry that video is so long.